Hello everyone, I am Karan Mashru. Welcome to this video. In this video, we are going to discuss solution of the problem of the day, that is partition equals subset sum. First of all, let us start by understanding the question. What does question say? It says that given an array ARR of size n, check if it can be partitioned into two parts such that the sum of the elements in both the parts is same or not. So basically we will have an array which contains n number of elements, and we need to partition the elements of the array into two parts such that some of the elements are in part 1 and some of the elements are in part 2, and whether the sum of the elements in part 1 is equals to the sum of the elements in part 2. Okay, now one thing to remember here is that each and every element of the array after partition should be exactly in one of the partition. Okay, it cannot be in both the partition, and no element must be missed out also. Okay, so each and every element of the array after partition must be exactly in one part, either part 1 or part 2. Okay, so we want to tell whether it is possible to partition the array elements into two parts such that the sum of the elements in part 1 is equals to the sum of the elements in part 2 or not. Okay, let us look at example for better understanding. Suppose my size of the array is 4 elements and the array elements are 1, 5, 11, 5. Can I partition the array elements into two parts such that their sum are equal? Yes. How? I can in one part I can take 1, 5, 5, and in another part I can take 11, and the sum of both these parts is same. Okay, so the output is yes. Here if I have 3 elements, can I partition this array into two parts so that their sum is equal? No, there is no way possible, so we will return no. Okay, our task is to complete the function equal partition, which takes n, that is the size of the array, and the array as input parameters, and returns 1 if the partition is possible, otherwise returns 0. The expected time complexity is n into sum of elements, expected auxiliary space is n into sum of elements, and the constraints are given here. Also n into sum of elements is less than equal to 5 into 10 to the power 6. So now if we think about solving this problem, so basically we want to partition our original array into two parts such that the sum of the elements in part 1 is equal to the sum of the elements in part 2. We need to check whether it is possible to do so or not. Okay, now understand one thing, for each element either it should be in part 1 or it should be in part 2. It cannot be considered in both parts, and no element should also be missed out. It means that ith element should be exactly in part 2, either part 1 or in part 2. Okay, it should be exactly in one part. Okay, so now see what I want is, I want that sum of part 1 is equals to sum of second partition. I am partitioning my array into two parts, or I can say two subsets. Okay, also I am not missing out on any elements, and no element is also repeated. All the elements are exactly either in part 1 or in part 2. So can I say sum of part 1 plus sum of part 2 must be equal to summation of all the elements of the array? I can say this, let me call it y. Now I want this to be equal. Okay, so let us call them x. So can I say x plus x must be equal to y? So can I say 2x must be equal to y? So can I say x must be equal to y by 2? So what I can say is that if I want to partition my array into two parts such that the sum of both the parts are same, then the sum of each part must be equal to total sum of all the array elements divided by 2. It is an obvious thing, it should be equal, right? Now understand one thing, from this we can conclude one thing. If the sum of the array elements is odd, we can never partition it into two parts such that the sum of both the parts are same, because in the input we are given integers. Now suppose my y is equals to 41, then my x should be how much? 20.5. I can never get this with the help of a subset of the array, because in array I have only integers. So first of all we will calculate sum of all the elements of the array y. If y is odd, we will directly return 0. If y is even, then we will check further whether the array can be partitioned into two parts such that the sum of each partition is y by 2. Okay, now I want to find two subsets such that the sum of their elements is y by 2. So even if I find one subset such that the sum of the elements is y by 2, my work is done, because I will consider some of the elements of the array in this subset, and if their sum is y by 2, then the remaining elements which I have not considered in this subset will form another subset, will form second subset, and the sum of those elements will also be y by 2, obviously, because the total sum is y is even. So if I can find a subset with sum y by 2, then the remaining elements will form a subset with the sum y by 2. So now my question boils down to what? Subset sum problem. What is subset sum problem? In subset sum problem, we are given an array and we want to find whether a subset exists with a given sum. But here we need to find, we are given an array and we need to find whether a subset exists such that the sum of that subset is equals to y by 2. If that exists, we will return 1, otherwise we will return 0. So now we have to solve this subset sum problem and tell whether a subset with sum y by 2 exists or not. So now how can we solve this problem? One of the ways is to find all the possible subsets and take their sum whether it is equal to y by 2 or not. How can we take all the subsets of the given array? How many would be there? 2 की power n, because for each element we will decide whether to take it or whether to not take it. We can do it by recursion. So if I try to draw a recursion tree, it would be of what type? In the recursion tree, let us take the remaining elements. Suppose the total number of elements are 6. So my question is whether I can form a subset with sum. What is the sum of all these elements? Let us find it out. So 6 plus 8 is 14, 14 and 10 is 24, 24 and the sum of these three elements is 10. So the sum of all these elements is 34, which is equal to y. Y is even. So now I want to find a subset with sum how much? 17, whether it is possible or not. So my recursion would be out of all the 6 elements, can I form a subset whose sum is equals to 17 or not, right? Now if I draw it here, suppose out of 6 elements, can I get a subset 17 or not? Okay, and for each index starting from end, I decide whether to take it or whether not to take it. Okay, because we have two choices for each elements, either to take it or not to take it. So for this element, suppose I decide to take it, so its value is 5. So now my question would be, can I form a subset from the first 5 elements such that its sum is 12? Because first I was considering all 6 elements, now I decided to take it. Okay, from the end I'll move and I'll decide whether I want to take it or not. So for 5 I decided to take it, so the remaining sum would be 12. And what can be the other case? Other case would be I decide not to take it. So my question would be, from the first 5 elements, can I form a subset whose sum is 17? In one case I decided to take it, in one case I decided not to take it. Now this recursion tree will go further. Now we are on this element 3. So I decide to take it. So the remaining sum would be 9. And I want to check whether sum 9 is possible from the first 4 elements. And in other case I decide not to take it. So out of the first 4 elements, can I form a subset with sum 12? And in this case also I decide to take 3. So out of the first 4 elements, can I get a sum 14? And I decide not to take it. So out of the first 4 elements, can I get a sum of 17? Now we are at this element. So either we will take it or not take it. So suppose we decide to take it. So out of the first 3 elements, can I get a subset with sum 7 or not? Because this value 2 would be reduced from this. And we decide not to take it. So from the first 3 elements, can I get a subset with sum 9 or not? Here also suppose I decide to take it. So from the first 3 elements, can I get a subset with sum 10? Or from the first 3 elements, can I get a subset of sum 12? I decided not to take it. Similarly here, if I decide to take it, then my remaining sum would become 12. And if I decide not to take it, then the remaining sum would remain 14. Here I decide to take it, the remaining sum would be 15, and if I decide not to take it, the remaining sum would be 17, and so on. Okay, so when will this end? When either the sum will become 0 at some point of time. So suppose we want the sum 17. How can we get it? We can get it from 5, 2 and 10, right? So I decided to take 5. Then I decided not to take 3, so I'll come here. Then I decided to take 2, and here I decided to take 10. So now my question would be, can I form a subset from the first 2 elements such that the sum is 0? As soon as I get the sum 0, it means that I have got a subset with the given sum, because here I have considered 5, not considered 3, considered 2 and considered 10. So 5 plus 2 plus 10 will give me 17. So as soon as I reach 0, what I'll do, I'll return true, that yes, I have found one subset. So basically, if there is xy, okay, and if it is like this, x1 y1 and x2 y2, so basically if either of these condition becomes true, this will become true, because basically what does it say? Can I make a subset of sum 17 with the help of first 6 elements, either considering the last element or not considering the last element? So any of these conditions return true, it will be true. This will be false when both of them will return false. So as soon as this will return true, this will return true, this will return true, and this will also return true. Okay, and it will end here. We will not go further because we have found a subset. What can be the other cases when we go out of the elements? Now here we have 2 elements left, then 1 element left, then 0 element left, but we were not able to find subset sum, or the remaining sum goes negative. In that case also we will not go further, because whenever it becomes 0, we have found a subset. So now in this, how many total, like what would be the time complexity for recursion? It would be, time complexity would be big O of 2 ki power n, because here we are considering all the different subsets. Like for each element we have 2 choices, either to take it or not to take it. So this would be my time complexity. So now I need to reduce it. So now I want to reduce from exponential to polynomial. Can I solve this problem using dynamic programming? I need to find whether there exist overlapping sub problems property. Are the same sub problems overlapped again and again? So if I see here I can see a sub problem which tells, can I get a sum of 12 with the help of first 3 elements with any of the subsets of the first 3 elements, and the same sub problem is repeated here. So there is overlapping sub problem property. Do we have optimal substructure property? What does optimal substructure property say? It says that we use the solutions of the smaller problem to calculate the solutions of bigger problem. We use the optimal solutions of smaller problems to calculate optimal solutions of bigger problem. Here also we are using it. So either this returns true or this returns true. This will return true. Here also either this sub problem or this sub problem will return true. This will become true. So we are using optimal substructure property as well as overlapping sub problems property, and we want to convert the time complexity from exponential to polynomial. So now we can here think of dynamic programming. So now if we think about solving it using dynamic programming, then suppose let us solve it with the help of tabulation approach. So in tabulation, what we do is that we will fill up the table, right? Now what would be the state condition? What would be the parameters that we consider? If we look at the recursion table, here we are saying, is the sum of 17 possible out of any of the subsets using the first 6 elements? What does this say? It says that is the sum of 14 possible out of any subsets of the first 4 elements. So we are considering first I elements and checking whether any of the subsets of the first I elements gives us the sum of j. So can I take one table dp of n plus 1 and target plus 1, where target is nothing but y by 2, because that is what I want to find. I want to find a subset with a sum y by 2. Here in this table, dp of ij will denote what? Whether a sum of j is possible out of any subsets of the first I elements. If yes, then this would contain value 1. If no, this would contain value 0. So now we need to fill this table. So first of all, let us fill the base condition. If the number of elements is 0, no sum is possible, because if there are no elements, how will we form any sum, right? So for, I can say for I equals to 1 to target, dp of 0i is equals to 0, because if no elements are possible, I cannot get a sum of I, right? Another base condition would be, if the target sum is 0, I can always get it using one way, empty subset. If the target sum is 0, do not take any elements. So empty subset will always have the sum 0. So now how will we write it? For I equals to 0 to n, dp of I comma 0 is equals to 1. Can we get a sum of 0 using any of the subsets of the first I elements? Yes. How? There is only one way. Take the empty subset. So we are saying it 1. Okay. So now we need to fill the remaining elements. So what we can say is, for I equals to 1 to n, for j equals to 1 to target. So now this will tell me whether dp of ij will tell me whether a sum of j is possible using any of the subsets of the first I elements. Now, so basically what I can do is, I can say, shall I consider the ith element or not? There are two cases. Now in order to consider the ith element, the value of the ith element must be less than equal to target. Suppose the ith element value is 10 and my target is 8, then it is impossible to consider the ith element. So if the value of the ith element, that is I minus 1, because here I am going from 1 to n, but the array would be 0 indexed. So if array of I minus 1 is less than equal to j, then dp of ij would be equal to, now I have two choices, whether to consider that element or not to consider that element. So if I consider that element, then my remaining sum would be what? J minus array of I minus 1, and I need to obtain that using the first I minus 1 elements, because I have got the ith element. So this will become I minus 1 and j minus array of I minus 1. So understand this. Suppose I consider the ith element, then the remaining sum would be what? J minus array of I minus 1, because the ith element has value this. So the remaining sum would be this, and I need to obtain it using any of the subsets of the first I minus 1 elements. So dp of ij is equals to this, or suppose I decide not to consider the ith element. So I need to find a subset using the first I minus 1 elements, and its sum would be still j, because if I do not consider the ith element, the remaining sum would be still j. So I'll tell whether I can find it using the first I minus 1 elements. Okay, but if the value of that element is greater than j, then I can definitely do not consider it. Okay, so in that case I would get dp of ij is equals to dp of I minus 1 j. So what does this basically say? Whether it is possible to get a sum of j, whether it is possible to get a sum j using any of the subsets of the first I elements is equal to whether it is possible to get a sum j using any of the subsets of first I minus 1 elements, because ith element I cannot consider it anyway. Okay, so we will fill this table using this. First we will fill the base conditions, then we will fill this table, and finally we will return dp of n and target. So what does this denote? Whether it is possible to get a sum of target, where target will be equal to y by 2 using any of the subsets of the first n elements. So if it will be possible, it will be equal to 1. If it will not be possible, this will be equal to 0. Now let's look at its actual implementation. So now if we look at the actual implementation, then what I have done here is I have taken one variable sum in which I have stored all the sum of all the elements of the array, right? So now first of all I'll check whether that sum is equals to odd. If that sum is odd, we cannot partition the array into two parts such that their sum are equal, will return 0. If that sum is not odd and if it is even, then we'll take target sum equals to sum by 2. Now our task is to find a subset with some target. Okay, so I have taken one dp table of n plus 1 and target plus 1. I have initialized dp of 0 I equals to 0, which basically denotes if my number of elements are 0, I cannot get any sum. Okay, so if the number of elements are 0, it is impossible to reach sum I, so it would be equal to 0. So dp of 0 I will be equal to 0. Now this base case, what does this denote? For I equals to 0 to n, dp of I 0 equals to 1. It basically denotes if I want to reach a sum of 0, it is possible out of any of the elements considered. Okay, out of, even if we consider first 5 elements or first 10 elements. And what is the way? Empty subset, do not consider any element. So dp of I 0 would be equal to 1. Then for I equals to 1 to n and for j equals to 1 to target, I'll go and I'll check whether now I want to fill dp of ij, which basically denotes whether it is possible to get a sum of j using any of the subsets of first I elements. Okay, So here I'll check whether I want to consider the ith element or not. Now I can only consider ith element for a sum of j if the value of the ith element, that is array of I minus 1, is less than equal to j, or j is greater than equal to that element. So if that is the case, then dp of ij equals to dp of I minus 1 j. If I do not consider that element, or I consider that element, then dp of I minus 1 and j minus array of I minus 1. The remaining sum would be this if I consider that element. But if the value of this element is greater than j, then obviously we cannot consider it in the subset. So dp of ij would be equal to dp of I minus 1 j. And finally we will return dp of n target, which basically denotes whether it is possible to get a sum of target using any of the subsets of first n elements. Okay, what would be the time complexity? The time complexity here would be, here this is the biggest for loop, this will take the most amount of time. It is nothing but n into target. Okay, n into target. And what is target? Target is nothing but sum of elements of the array divided by 2. Sum of elements of the array divided by 2. So 2 is a constant, we can ignore it. So it would be big O of n into sum of elements of the array. And what would be the auxiliary space occupied here? The auxiliary space occupied here will be equal to n into sum of elements, because I have taken one dp array of size n plus 1 into target plus 1. So which is basically nothing but n into target, 1 is constant, which will basically turn out to be big O of n into sum of elements of the array. So our auxiliary space and the time complexity are both same, big O of n into sum of elements. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you.